This video is on exponents and the rules for exponents. So basically, I'm going to remind you what an exponent is. You probably already know, but this, when we have 2 to the third power, the 3 is the exponent, and the 2 is called the base. So we can have all kinds of exponents, all kinds of numbers. You can also have an unknown variable to be the base. So the 4 would be the exponent here, and the a would be the base here. So a to the 4th. And exponents again means for 2 to the third means you have 3 of these 2's multiplied together. The exponent tells you how many times to repeat the base. And then if we simplify that or evaluate, it's 8. For a to the 4th, that's the same thing as 4 a's multiplied together. Since a is the base, that's what's repeated, and it's always multiplication. Exponent tells you how many times to repeat it. And we can't evaluate that because we don't know exactly what a is. So that's all we've got there, just to remind you what exponents are. So we have 3 rules we'll go over with exponents. The product rule, remember product means multiplication. You might want to write that, multiplication. And so, for example, if we have 2 to the third times 2 to the second, it's 2 squared, and this is also called 2 cubed. You can use whatever terminology that you want. This is the same thing as 3 of those 2's, right, multiplied together, times 2 of those 2's multiplied together. And so that's the same thing as 2 to the 5th. And you can evaluate that in your calculator or think in your head what that is, but that equals 32. We always evaluate exponents with numbers if they are numbers. With unknown variables, we can't. So what I'm going to cover mostly is problems with variables. Some numbers will be in them, but I just wanted to start with what you know, which is numbers and exponents. So when we have 2 to the third times 2 squared, we can do a sort of shortcut where we just add the exponents, because that is 2 to the 5th as well, which equals 32. So I wanted to show you that you can just add the exponents, and here's the proof, what we call the proof. You know, you can write out 3 of those and 2 of those, and so there's 5 of those. So you can always just add the exponents. That's the product rule. I'll show you another example. I'll squish it in. Right here. So if we had, let me just erase this 32, because we definitely evaluate problems that have numbers in it, but it's not the point here. And so if we had, a 7 to the third times 7, and yes, this always has to be multiplication because it only works with the multiplication. There can only be 5 2's multiplied together if it's all multiplication. So 7 to the third, I'm making up a whole other problem. 7 to the 4th. You guess what that would be? And we'll check, if we wrote out 3 7's multiplied together, that's what this is equivalent to, 3 7's, and then it's multiplied by 4 7's, because that's the definition of exponents. You can count how many 7's total you have, which is actually 7. So 7 to the 7th power. So this is actually the same as just adding the exponents. That's kind of a shortcut thing you can do. And then, of course, if we were actually doing this problem on a homework software program, Alex, whatever, on paper, we'd actually write the answer to this. I would use my calculator. And so since that's going to work with every real number, we can write that in terms of general, just unknown variables. Say x, any number x to the 5th power, and we have x times x to the 6th power. So x to the 5th times x to the 6th. Guess what you can do? You can use what's called the product rule, since we have multiplication, and just add the exponents. So with the product rule, you add the exponents. See that? X to the 11th. I'll give you another problem before I show you what kinds of problems that Alex shows you in the homework. Say we have y to the third times y to the 11th. You can write out 3 y's and 11 more y's and count the whole thing, you know, but you know this works for any real number. This is how we come up with these rules. We look at real numbers and it's always true, so we can say this is a rule. So that equals y to the 14th. Just don't accidentally multiply these, so you really got to watch. So you want to write in words what that rule means. And then in Alex, this is what the name of the concept is, one of them. Product rule with positive exponents, univariate. So who goes around talking like that, you know? I'm just putting this so you can match the homework problem with your notes. Univariate means one type of unknown variable. So here's one problem we're going to look at, and here's the second problem we're going to look at. This has only w's in it, so that's what it means, univariate. And so now what we do here, we have negative 2w to the third times negative w to the third. That's really a negative 1 right there, we know. What you do is multiply those numbers. Negative 2 times negative 1 is 2. And then you're going to multiply, because this means multiplication as well, w to the third times w to the third. And that's w to the 6th. 3 plus 3. And that's it. For this problem, we have negative 3 times 9. We just look at the numbers first. That's negative 27. And then v to the 8th times v. Anytime a variable is sitting there by itself, it really has a 1 as an exponent. And so v to the 8th times v to the 1st. You know what exponent goes right here? 8 plus 1 is 9. So you don't need to show any other work. I mean, unless you want to, you know, show v to the 8th times v to the 1st equals v to the 8 plus 1, and that equals v to the 9th. But just add the exponents when you're multiplying the bases. Add the exponents when multiplying. That's the product rule. The bases. Okay? I like 3x5 cards. I would put product rule for exponents at the top and put some examples that you like, makes sense to you on there. And then have another card for the next rule and another card for the next rule. Or if you like, just one sheet of paper. Now we have product rule with positive exponents, multivariate, so that means, you know, more than one type of unknown variable. So if you look at this problem, we have x's and u's in it. That's all that means, multivariate. I've never described a problem like that. I guess it's just specifics for the curriculum developers. But this way you can match your problems in your notes with what you see in the homework. And so this is 4x to u6, 3x to the second, u to the fourth. So 4 times x times 2 to the u to the 6th, 3 times x squared times u to the 4th. You can say that 3 times fast. Just see the numbers and multiply those. 4 times 2 is 8, 8 times 3 is 24. And then we look at the x's and we add the exponents. This really has a 1 on it. So it's going to be 24 times x to the 1 plus 2 is 3. And then we need a u in there. And we're to simplify. The instructions always say simplify for this homework section. And u to the 6 times u to the 4th is u to the 6 plus 4, which is 10. That's it. Okay. For this problem, we have v's and y's going on. We're going to start with the numbers. 3 times 5 is 15. 15 times 3 is 45. And then we're going to have a v and a y in there and put our exponents in there. So this v has a 9 and this one has a 4, v to the 9th, v to the 4th, times v to the 4th. So that's 9 plus 4, and so that'll be 13. And then with the y's, v to the 3rd times y to the 1, y to the 1st power, 3 plus 1 is 4. So that's your answer right there. If you're multiplying the same bases, the bases have to be the same, then you can add the exponents. Next we have what's called the quotient rule. So I'm going to teach you some basics about the quotient rule. So I'm going to start with x's. Say x to the fifth over x to the third. And to write that out, we have 5 x's on top, right? Because that's what exponent means. Exponents mean. There's 5 of those x's repeated, and on the bottom we have 3 x's. And so you know you can cancel one thing on top with one thing on bottom. So we do that, one on top with one thing on bottom. That is the same. And we have 2 x's left on top. So that really means x squared over 1 or x squared. So look at this, how that equals x squared. So I wrote it out to kind of prove it, but also what we can do if we have x to the fifth over x to the third, we can just subtract the exponents and get x to the square, x to the second, x squared, okay? So you subtract them from top to bottom. If the bases are the same, you can subtract the exponents. So multiplication corresponds to addition with the exponents. Division, that's what quotient means, is division, corresponds to subtraction of the exponents. I'll do a different problem. So say we're looking at a to the 7th divided by a to the 5th. Well, that's going to be like the same boring number. A to the 3rd, what the heck. Okay? So you can see that we have 7 a's. You don't always have to write this out, but if you write it out, you won't go wrong. Is that 7, 1, 2, 3, 4, 5, 6, 7, and then 3 a's. And you can cancel 1 on top with 1 on bottom. Cancel 3 on top with 3 on bottom, and you see how many you have left. So that equals a to the 4th. You can also just subtract the exponents. You can do this with numbers too instead of unknown variables, and you'll see that it's the same thing. So when dividing bases that are the same, subtract the exponents. And that's your quotient rule. Now I'm going to show you some problems that Alex gives you, simplifying a ratio of multivariate monomials basic. So that's the name of this concept. So for this problem, we have 45wx divided by 72xy. And so we got to look at the numbers first and simplify as if that's just a fraction of 45 over 72. So I have to think of factors of each, like the biggest factor preferably. I don't think 45 goes into 72, but I know 9 goes into 45, so these are both divisible by 9. So that'll be a 5 left, and then 72 divisible by 9 is an 8. So I've got a 5 on top and an 8. It's like I reduced that fraction, that's all. Now this w is sitting here. There's no w on the bottom. Nothing's going to happen, so that stays in there. And the y doesn't have anything else, no other y on top, so that's going to stay in there, right where it is. But we have an x on top and an x on bottom, and anytime you have one thing that's the same on top as the same thing on bottom, they cancel. So this is your answer for that one. We didn't really use, we kind of used the quotient rule, but it wasn't very exciting. But these are problems that Alex gives you. Now for this problem, we have 25xy divided by 45xy. So it's like we first got to look at the numbers and simplify that fraction. So 5 goes into each, in which a 5 and a 9 are left, so those go right here. And the W sitting there with no W on the bottom, so that's going to stay in there. The X's, there's one on top with one on bottom, so I can cancel those. Same with the Y's. And so that's it. 5W over 9. In the next problem, we actually have exponents on our variables. This is called simplifying a ratio of univariate monomials. So what we do is look at the numbers. 7 does go into 28 evenly, so we're going to have a 4 left on top. Now we have 4 x's on top and 7 x's on bottom. You can imagine writing out 4 x's on top and writing out 7 x's on bottom and canceling one on top with one on bottom. You can actually write them out if you want, but you want to get to the point where you're not doing that. Or you can just see that you'll have 3 x's left on top, because the difference between 4 and 7 is that. So I'm going to write that out though, just to show you that x part, just the x part. I got 4 x's on top, all being multiplied together. And then I have 7 x's on bottom. And 1 on top cancels with 1, same thing on bottom. So I have 3 left on bottom, and exactly on the bottom, so they got to stay on the bottom. And then that's your answer. So that's what's going on with the x's. So you can have x's left on top or x's left on bottom, or y's or whatever. So for this problem, 9x to the 5th divided by 45x. 9 goes into 45 5 times. So what I'll have is a 1 on top and a 5 on bottom. And here I have 5 x's and here I have 1x. So 5 minus that 1 is 4. So we really don't write that 1, so the answer would be x to the 4th over 5. So you can write out 5 x's and write out 1x on the bottom, cancel the 1 out on top with the bottom, and see you have 4 x's left on top. So that's using the quotient rule. Now we're looking at quotients of expressions involving exponents. It's just more of the same. It's not as much numbers, I guess. So for this problem, z to the 3rd times y to the 7th, a to the 4th, divided by z to the 5th, y. This is where I emphasize again, make sure your z's don't look like 2's. So I put lines through my z's. See the 2's over here? Because when you're writing fast and stuff, they'll start to look like z's, and you'll get confused and mess up the problem, or your instructor can't see your work. My 7's, I put a line through them so they don't accidentally look like 1's. So those two specific types of numbers. So for this problem, you can look at the z's. You have 3 z's on top and 5 z's on bottom. Do you know where you'll have leftover and how many? The difference between 5 and 3 is 2. You'll have 2 left on bottom, so you write it like that. And then look at the y's. There's 7 y's on top and 1 y on bottom. So you'll have leftover on the top, and you'll have 6 y's left over. And then with the a's, you don't have any a's going on the bottom, so that stays on the top. So, you know, if you want to write this nicer, y to the 6th, a to the 4th over z squared is your answer. Now for this one, we have 6 b's on top, 1 b on bottom. So we're going to end up with 5 b's on top. And then with the a's, you have 4 a's on top and 3 on bottom, so 4 minus 3 makes a 1. We really don't write that 1. And there's nothing left on bottom. You always put a 1 if there's like nothing left on bottom or on top. And that's the same thing as just b to the 5th a. Because we don't really write that 1, and we don't really write the 1 under it. So for this problem, we have a's going on here, 2 a's on top, 2 a's on bottom. Those actually just cancel totally, however you want to really make that clear. the 2 just has, just sitting there, so it's going to stay there in the answer. And for the b's, there's 5 b's up here and 4 b's down here. So you have one more b going on. So it's really just b over 2 is the answer. So it looks like a z, but I didn't put a line in through it, so I know it's a 2. So that's how you do that. So for the next type of problem, this is simplifying a ratio of multivariate monomials advanced. So we just have some more numbers going on in this problem. So you see the 9 and the 36. 9 goes into 9 one time, 9 goes into 36 4 times. So we're going to have a 1 and 4 there, just as if we simplified that fraction. Now with u's, you have 5 u's here and 3 u's here. That means we're going to have 2 u's on the top left over. And do you know what will happen with the v's? So we have 4 v's up here and 1 v down here. That means we'll have 3 v's left over here. 4 minus 1 is 3. So really rewrite that as u squared v cubed over 4. And now we have 16v to the third times w to the fifth over 40v to the fourth times w to the third. So we're going to look at the numbers first and simplify those. I don't think 16 goes into 40, no, 8 goes into 40, so 8 into 16 is 2, 8 into 40 is 5, so we have a 2 and a 5 here. And if you look at the v's, we have 3 v's on top and 4 v's on bottom. We have more v's on bottom, and the difference is 1 v. And then with the w's, you have 5 w's on top and 3 w's on bottom. So you'll have 2 left on top. So it's 2w squared divided by 5v. And those are the 2 rules. So we've only used the product rule, and then separately in other problems we use the quotient rule. Now the third rule we'll look at is the power rule. So for example, here's what we mean by a power rule. If we had a squared and all that was being taken to another power of 3, so we can do something with those. So let's see what this means though. So in this case, this is the exponent and a squared is the base. So that's the same thing as writing 3a squared multiplied together. So the base is repeated or multiplied 3 times. And of course you can write that out more. That's a times a, and this is a times a, and this is a times a. And we know all of that is the same thing as 1, 2, 3, 4, 5, 6, a to the 6th. So if you look at these numbers, how would you get a 6 out of those? You just multiply them. So we can also say a squared to the third is the same as a to the 6th. Or I'm going to write 2 times 3. It's the same as multiplying those numbers, and that's a to the 6th. So that's the power rule where we can multiply. If one exponent, I usually say it this way, if one exponent or the base of and an exponent is being taken to another exponent or another power, we multiply the exponents. So here's another example just using the power rule. Say we had b to the 5th to the 11th power. So you can write out b to the 5th 11 times like we did here, and then write out all those b's and count them. You're going to get the same conclusion when you break it down, and you'll see that it's the same as b to the 5 times 11, which is b to the 55th power. So you multiply exponents when one power is being taken to another power. Here's another problem, x to the 9th to the 2nd power. You know what that'll equal? all you do is multiply the exponents. That's the same thing as x to the 9 times 2, which is x to the 18th. So you multiply the exponents. I'll write this rule here if one power or exponent, see, one power is raised or being taken to, I mean, depends on which English that you like to say, another power, then multiply the exponents. Okay, that's the power rule. So Alex has you answering problems that look like this. Understanding the power rule of exponents is what this is called. So for this first problem, write 4p to the 4th squared without exponents. So just write it out, basically, is what it means. So there's two of these things here going on, the bases. So what you would type in here is 4p to the 4th times 4p to the 4th. Two of those. That's what the answer is for that. Write it without exponents. Well, I guess not. I guess they want you to break this down further. So let me take this down here. That's the first step. So you'd multiply the 4s, which is 16, and p to the 4th times p to the 4th is where you add the exponents. So that's p to the 4 plus 4, and that will equal 16 p to the 8th. Now, I'm not sure how this is different from that then. Maybe, I don't know if they want you to write 8 p's out, but in either one of these, you're going to write it without exponents. So that's the same problem here as above, 4p to the 4th all squared. So what you would type in here is 16 right there, and then you type in an 8 right here. I don't know why, what would be different there. Maybe they don't want exponents though, so I'm not sure if they want 4 times 4 times, 8 p's. But you can look at the explanation example. 1, 2, 3, 4, 5, 6, 7, 8. That's without exponents. So for this problem, we have y squared to the 3rd. That means y squared 3 times. So I don't think that's why I'm not thinking that's the answer, because that actually has exponents in it. And then you could just write out 6 of those. Maybe that's what they're looking for. And then you type in a 6 here, because to multiply the 2 and the 3. So that's the same thing as y to the 6th. In the next problem, we have negative 4a to the 4th b squared all to the 3rd power. So that means you're going to take everything to the 3rd power. So that means this negative 4 is taken to the 3rd power as well, because it's inside those grouping symbols, the parentheses. So you have to take that to the 3rd power as well. So I'm going to write that just so that you look back at your notes and you see that for sure. Now I'm going to multiply the exponents, because a to the 4th is being taken to the 3rd power, so that's a to the 12th. B squared to the 3rd power becomes b to the 6th. And now I have to think about now if I want to look at negative 4 to the 3rd power, I'm going to take that separate from my work for that problem. That's going to be a negative number, because this part is 16, and then I have 16 times negative 4, which is negative 64. So negative 4 to the 3rd is equivalent to negative 64, and so I have a to the 12th, b to the 6th. So don't do this work in the middle of your work. Here's your original problem. Do your work one step at a time, line by line, and do this kind of work aside if you need. Now for this problem we have negative 2ba squared all to the 5th power. So that means negative 2 to the 5th power, as well as b to the 5th, because there's really a 1 right here, and you multiply the exponents. 1 times 5 is 5. And then a squared to the 5th power is a to the 10th, because 2 times 5 is 10. Now you can write this out and figure it out, but I know this is negative 32. Negative 2 to the 5th is negative 32. You can check on your calculator or write it out. So we have b to the 5th, a to the 10th, and that's your answer. So we're using the power rule here in these problems. That's the 3 rules, and that's the only 3 rules we'll cover for this section. So this problem involves some division here, quotient going on, power rules with positive exponents, multivariate quotients. So we're just using the power rule with division going on. And so everything, each little thing needs to be squared here. Negative 8u divided by w to the 3rd, all squared. So this negative 8 has to be squared. U is going to be squared because there's really a 1 here, and 1 times 2 is 2. And the w has a 3 there, so 3 times 2 is 6. And negative 8 squared is 64, so the answer is 64u squared over w to the 6th. For this problem, a squared divided by 2b to the 4th is taken to the 4th power. So the a is 2 to the, and then also to the 4th power, a squared to the 4th, so 2 times 4 is 8. Just don't accidentally add those, just try and catch yourself. And then 2 has to be taken to the 4th power here, and then the b is to the 4th power and to another 4th power. So that's where we multiply the exponents, and that's a 16. And so that's a to the 8th over, and then 2 times 2 is 4, and then again is 16, so that's times b to the 16th, and so that's your answer. Now here I forgot a parentheses, but we have negative 3x to the 3rd times z to the 4th all to the 3rd power times 3x squared y to the 3rd z to the 2nd. This is called power and product rules with positive exponents. So we're going to start using 2 rules in one problem. And we definitely can use all 3 rules in one problem. There's another rule that we'll probably go over later in the next section called negative exponents. Whatever is, I don't know that's called, there's not a rule for it necessarily, a name for the rule, but we deal with negative exponents, so we could mix those in as well. So first thing we do is distribute sort of this 3. Everything needs to get that power of 3. So negative 3 to the 3rd. Then that x is going to have a 9 on it, right? 3 times 3. Z is 4 times 3 there, so that's to the 12th. And then this is all just multiplication. So don't really need those parentheses, and I'm just going to write that down because that does not have an exponent right here. Now I can evaluate this. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Okay, so the number's done. We'll actually have another 3 here, so I'll deal with that later. And then I guess I don't have to write that multiplication sign, but that we have x to the 9th, and then over here we have x squared. And those are just multiplied together. Everything's multiplied together. So we add those exponents. So this will be x to the 11th. And then to keep it in alphabetical order, I could keep the y to the 3rd here because there's no other y. And then this z can be combined with that z. Z to the 12th times z to the 2nd is z to the 14th. 12 plus 2. Then we have that times 3 going on. So negative 27 times 3 is negative 81. So then we have all of this. Negative 81, x to the 11th, y to the 3rd, z to the 14th. So we use the power rule first, and then we use the product rule for bases that are the same. So I only have like 3 problems left. And it's the same concept for all these power and product rule with exponents. And I suppose the quotient rule would be mixed in as well. I don't remember it being called something different on Alex. Now if you look at this problem, negative x z squared all to the third power times x squared y z to the third power. First I'm going to deal with this part, and this is like a negative 1 right here, so I've got to recognize that's being taken to the third power as well. And then this will be x to the third, because there's really a 1 right here. 1 times 3 is 3. And then z to the 6th. And then I just have x squared y z to the third. So negative 1 to the third power is negative 1. Then with my x's, see here, x to the third times x squared. There's not a power being taken to another power. It's just the bases are being multiplied. So we can add the exponents. So 3 plus 2 is 5. And then the z's, 6 and 3 is a 9. And then we have that y hanging out in there. So I'm going to write this without that 1, which we don't really write. And we usually write it in alphabetical order. So negative x to the 5th, y times z to the 9th. Okay, so now with this problem, there's 2 different ways to do this. You can simplify what's inside first and then take it to the 4th power, or you can distribute this 4 and then simplify. So with exponents, a lot of times, especially with the big messy problems I call it, there's more than one way to do it. But I'm always going to distribute first. I'm going to just distribute this 4 to everything first, because that's a good habit when you get into the negative exponents. I think it's the best way to do it. So the 2 has to be taken to the 4th power. That m becomes 3 times 4, so that's 12, because that m to the third is being taken to another power. So we multiply the exponents. The n will be 5 times 4, so n to the 20th. This 4 is also being taken to the 4th power. N squared, so that'll be 2 times 4, which is 8. Now we have this problem. So 2 to the 4th is 4 times 4, that's 16. M to the 12th, there's no m's down here, so I can just leave that m there. And then with the n's, I have 20 n's up here and 8 down here. That leaves 12 n's up here. So I'll have no n's here. And 4 to the 4th is 16 times 16, which I can just pick up my calculator and do it, or do it real quick here, which is 256. So 16m to the 12th, n to the 12th, divided by 256. So let's see if we can reduce these numbers here and just see what 256 divided by 16 is. And that's 16. So there'll be no number left on bottom, just a 16 on, no number left on top, but just a 16 left on bottom. And on the top we have m to the 12th, n to the 12th. And that's it. And so for the next problem, the last problem we'll do, see what we have here, x to the 3rd times y to the 4th divided by x squared times y, all to the 5th power. You can totally simplify this first and then take what you have and take it to the 5th power, or you can distribute that 5 to each thing, which it might seem crazy, but I'm going to do that to get you in that habit, because it's going to help when we have negative exponents going on. So x to the 3rd to the 5th power will make x to the 15th, and y to the 4th to the 5th power is y to the 20th. Multiply the exponents, and then x squared to the 5th is x to the 10th, and then that y really has a 1 there, so y to the 1 power and also to the 5th power, 1 times 5 is 5. So now we can use the quotient rule. We have 15 x's on top and 10 on bottom. You have more on top than bottom, so you're going to have 5 left over on top. And with the y's, we have 20 on top and 5 on bottom, so you're going to have 15 left on top. 20 minus 5, there's like a 1 left, or you don't even have to write that part. So the answer is x to the 5th, y to the 15th. And that's it for this section. Hopefully that gets you started okay on exponents and explains the 3 rules for exponents.